Good morning, everyone, and thank you for taking the time to attend DataSeer's first webinar of 2022, Digitization of Industrial Diagrams through AI and Computer Vision. My name is Brad Clark. I'm the Strategic Account Executive here at DataSeer, and I'll be your host for today's webinar. We are joined today from the DataSeer team by Ting and Joe Orlich. Joanne is the CEO, President, and Technical Co-founder of DataSeer. She has a PhD in computer science in the area of machine learning for control and robotics. We're also joined by Joe Orlich, who is the customer success manager here at DataSeer. He works with our partners and users to help them fully realize the value of the DataSeer solution. Now, before we begin, I want to mention that this will be recorded and shared with all attendees at the conclusion of the webinar. I wanted to quickly go over the agenda and how the time will be spent today. The first topic will be, why is data extraction from P&IDs so hard? Joanne will cover the state of the data extraction landscape as it exists today, safety issues, and the machine learning approach to these issues. Once Joanne has finished the discussion on these topics, Joe will provide a short live demo of a machine learning tool and how it can be applied to auto labeling. Next up will be a high-level overview of computer vision and machine learning methods and image recognition. Here, Joanne will cover what is computer vision, show some examples of detection, recognition, and segmentation in a document, some machine learning challenges, and then highlight some different detection and recognition techniques for both computer vision and machine learning. Once Joanne has finished her discussion on these topics, I'll be back to Joe for another live demo of the machine learning tool on a few other use cases, including tag extraction from electrical wiring diagrams, as well as table extraction from data sheets. And we'll then wrap things up with a Q&A session for all attendees. Now, participants will be able to submit their questions in the Zoom Q&A during the webinar, and I'll collect and curate these questions for the Q&A session at the end. And you will be able to upvote on these questions, which will help to prioritize which questions are most important to the audience. So please do use this upvote feature. And if there's any questions that we don't get to because of time, we will answer those offline via email. And with that said, let's go ahead and get started. Joanne, the floor is yours.
Thank you, Brad. Good morning, everybody. Good afternoon, depending on where you are. As you can see, it's morning on my time. There's a sunset rising, so apologies for the glare. But for this first part of the session, I'll introduce the problem of data extraction from specifically P&IDs and give you an introduction on why it's so hard in particular. So just really quickly, P&IDs and industrial schematics, these are typically available in PDF or paper image form, especially for brownfield to legacy projects, but also when you're sharing diagrams right across organizations. It's very rare to get the source CAD formats when you're sort of IP sharing. And then the second point is engineering standards, symbologies regarding P&IDs. These are guidelines, but they're not really hard rules. And they not only evolve over time, but depending on the team, the client, the engineer, they have slight variations. And then finally, when working with these diagrams, legacy diagrams, extracting data, trying to digitize these diagrams, this is currently today a very highly manual and time-consuming process. It's not only prone to human error, but it also requires typically, QA/QC, someone else to verify and check your work. So for all these reasons, this is why today it's actually quite a big and open problem. Layer on top of this, the fact that a lot of these systems that these diagrams capture are actually sort of, industrial processes that when you make a mistake, has actually pretty high implications in terms of not only cost, but also safety. So as an example, here you can see I've included, 3 different variations of what ball valves could look like, and also 2 different ways of denoting electrical lines. One takeaway here is, there are ambiguous representations. And, this is why you have legend sheets, right? That go along with your projects, although that's not always available. And depending on, the organization, the team, the design engineer, these symbols might actually mean different things. So really what we need here if we wanted to extract data and digitize these diagrams, we need to find a way to gather the context and also gather customization and preferences from the user when interpreting and recognizing what's on the page. And then in terms of how you would do this in a machine learning paradigm, a lot of people might think, oh, well, we can use AI. This can be a fully automatic solution. Well, that's true. You can. But there are trade-offs, actually, as you can imagine. If you need to incorporate sort of user feedback, get context, find out customized preferences from the user, you might actually need to embed the user, the engineer, as part of this machine learning solution. And so here we have sort of a trade-off table, I guess you could say, pros and cons with regards to deploying or developing a automatic solution. So it's great if you actually don't want a human involved. You want a one-button solution to just give you an answer. But you might actually suffer from lower performance because of underfitting. And simply what that means is you might actually not know specifics about what the particular engineer is looking for, right? Or what kind of diagram is being processed. So in that sense, a fully automatic one-button solution doesn't account for specific preferences or specific conditions. However, if you are actually fine with a rough, high-level estimate of what's on the page, a one-button solution might actually be fine. Now, the trade-off is, of course, if you are interested in accuracy, and not everybody, is interested in 99.99% accuracy. If you are interested in accuracy, the resulting work and effort it takes to review the predictions and to correct mistakes might actually far exceed the time it would take, right, if you were to do this manually, for example. Ultimately, where a fully automatic solution actually makes sense and fits is one where the data distribution, in this case, think diagrams, right? The types of diagrams that you see remains the same. What you've seen in the past is 100% reflective of what you've seen in the future, right? And if that's the case, then you should go ahead with your, fully automatic approach. But if you know the data distribution, i.e. the diagrams, the types of diagrams, styles of diagrams, even the tasks you'll be, faced with in terms of processing these diagrams, if you know these things are actually going to be changing over time, this is where it actually makes more sense to embed the user, the engineer, as part of this machine learning solution and system. So with that premise, there is now a short demo that Joe will give to just illustrate this automatic versus human loop approach. Joe?
Thank you, Joanne. I will start sharing my screen. So for today's demonstration, I will be going through a use case of a material takeoff. This is the idea of having a set of diagrams and you would like to collect a number of, say, valves, specific types of valves on these diagrams so they can be enumerated and essentially get a rough order of magnitude of the project in itself and capture exact counts off of these specific pages. To do that manually is going to be very time consuming, having to go in and mark up those pages themselves. So using DataSeer as an example here, we'll be going through a machine learning approach to that same process. Just to fully cover this use case, I'm going to do an upload to the system so we can see how DataSeer will configure this information. So configuration is a very important step in going through DataSeer, in the sense that this is a chance for you to tell DataSeer what library to reference when this auto labeling process to follow occurs. We have our own curated library of common P&ID symbols that we've built over the years. This is set to the ISA standard, so very common ones that you'd see on any given diagram. I'll go back and also show you a template. A template is a library that a user themselves begins to curate over time. It can be use our own embedded symbols, as you see here, but also customize symbols off of the page. This way they can utilize the machine learning aspect and incremental learning aspect of DataSeer's platform to begin fitting models to those specific symbols themselves. So if there's anything that's starting to diverge from this standard or a totally different standard entirely, the user can start to build that out and have their own library to reference so they can have increased efficiencies over time. They wouldn't have to necessarily go back and remark that up when they come back to a project because that symbol didn't exist before. So I'll simply use this demo template as the template and process this project. Now this will begin the process within DataSeer, and it will search those diagrams that we've uploaded a moment ago and attempt to apply a label from that library to every symbol that's on that page. I'll forgo waiting that processing and open up the same project here. And we'll get a page-by-page view of this project and what has been applied to it. This is very close to a final output of a project in having auto label run and also adding some symbols that may have been outside our library during the upload step. But as you can see here, everything that has a color assigned to it, a color overlay, if you will, is a label that's been applied by DataSeer's auto label process. If I double click on a given symbol, that will expose that actual data point within our database. This is an instrument label that's been applied to this specific symbol. I'll zoom in for high resolution for the team. And I'll also open our instrument tab in its totality here. So these are all the instruments that have been collected, 199 instances across our 5 pages of our project. Every single row is a specific instance of that instrument. That way it can be exported from the system. And this table would be the export itself that comes from DataSeer. That way you have a row by row insight to every symbol that's detected, so it can be collected and enumerated in the process of a material takeoff. To further highlight the efficiencies that the solution of machine learning can bring to the labeling process, I'll actually go into some symbols that I actually removed the label for, so you can see our search feature. I'll go into this safety instrument here. So say in the course of your project, this is a auto label didn't capture all of your project symbols, there didn't hit the threshold for labeling, or this is a totally new symbol potentially that DataSeer hasn't learned yet. You're able to go in and annotate this symbol, and then DataSeer will begin to search your project for potential matches. As you can see here, you can limit your search to your current page or all pages and change the orientation if it was a type of symbol that has orientation change on a P&ID. During the step here, I'm going to choose a label to give it on onset. If there's already a label in the system, there's going to be its own classifier model built to that specific symbol that it will continually reference and use to learn and take feedbacks to improve on subsequent runs, both in this project and future projects. If there's a new symbol, it would use a base classifier model and then begin to learn following this initial search. So now DataSeer is going to search the totality of our project and look for all unlabeled data and attempt to apply this label and give it a score of confidence of how certain we are that this is indeed a matching symbol. As you can see here, we assign a threshold score as displayed in the bottom right of each symbol on the given page. If I push it lower, it'll expose more matches that are potentially on this page. There's no other on this page. I'll move to separate pages to show. You go to different pages, it'll show you everything that's above the given threshold you're at. If you go down extremely low, you'll get worse and worse matches. Here, as you can see, this diamond symbol has been falsely identified at this very low threshold that I've set during this search. I can simply tell DataSeer at this point to omit this, or just keep my threshold higher so I don't get anything that's that low of a confidence during this labeling step. If I'm happy with the labels that have been applied and everything that's been in my search, I can save it. And what we do here is we both apply a label to everything that has been included within our review results search page. And we're also update that model. So if we were to run this again, either in this project or subsequent ones that I saved as a template, we would get those efficiencies in terms of updating about what more positive results and which ones have been told that are negative thus far. At this step here, because I have a label assigned to a symbol, I'm now able to go directly into the find attributes step. Finding attributes is a part now on the computer vision side of the solution. Once you have a label assigned to a symbol, you're able to then extract that critical attribute data from either the surrounding or inside the symbol itself to forego having to manually update that after a symbol has been applied. And you will see on this form here, we do have regular expression inputs. This goes back to the importance of the human in the loop factor, both in the reviewing the results and QAing to make sure that you have correct results on that page, but also being able to put regular expression patterns that capture accurate data. And very dense diagrams, there can be a lot of text data in the surrounding area for something like a valve. Giving this correct input in terms of regular expressions will give you and glean you better results in terms of correctly identifying what is in the sense of a valve, a ID or a size attribute for those types of symbols. But in running find attributes, you're going to quickly collect the data for that given symbol type, and it will be put into a quick review space to see the data that has been collected off of those symbols. I can go and review these individually in this stage here. And in this space here, I can say to look and accept this, or I could even reject it if I wanted to retain the current values that are in that space. I'll forego that here. And I'll click OK to move that data into the output file. And with that, I've collected all the symbols on this page, and I could simply then need to export this data in its totality outside the project to then do a collection or enumeration of these symbols. And with that, I will conclude, that concludes this specific use case. I'll stop the screen share and I'll pass it back to Joanne for the second phase of today's presentation.
Thank you, Joe. And hopefully you guys have seen, the trade-off between having a fully automatic, right, off-the-shelf model that's able to recognize symbols, and then having sort of the user preferences be solicited, right? So that way we can actually create and give you the results you need without necessarily creating more work for you, right, to correct and review. Because a lot of this data extraction, or even this act of digitizing, is actually work that needs to be rechecked and reviewed. Moving on to the second part of this webinar, this is the more tutorial part. And I'm going to try in about 10 slides to give you a crash course on computer vision and machine learning, something that could easily take an entire semester or entire year in college. So here we go. So really, you might be asking yourself, what is computer vision? I've been hearing it, I don't really understand, what it tries to do. Simply said, computer vision, it is what it sounds. It's basically computers trying to understand and automate things that we as humans do visually with our eyes. So what are some of these things that we do so naturally? So here are some examples. Detection. So detection is basically the problem of figuring out where in an image should I look? Where should I look, right? Recognition is one where, given I tell you where to look in an image, can you identify what it is you're looking at, right? That's the what. And then tracking is something that's often really for video, right? Imagine you're watching a soccer match. You're trying to follow the ball, right? That's tracking. And segmentation is a problem where I could give you an image crop, say, a picture of the beach, and I say, well, part of this is sun, ocean versus sky, right? So that's segmenting foreground and background, for example. Here's an example on a P&ID, a sample P&ID that we have. And you can imagine things you might be interested in detecting, extracting would be, items on the right. So the detection problem would be like this. Where should I look at in this P&ID to find a pump, right? And so, what would you do as a human? You'd probably start looking zigzag with your eyes, either top to bottom or left to right, depending on what you fancy. And then you realize, here's a pump, right? So the detection problem is, where in this image should I look at to find a pump? Recognition is, once I have a focal point, what is it I'm looking at? It's a pump, right? And segmentation, here's an example. We have a title block down below. I could give you the crop of the title block and say, tell me what part of this image is the logo, right? So here we can visually with our eyes segment out logo from everything else in the background. Now, moving on to the second concept here, machine learning. How does machine learning fit with computer vision? So first of all, machine learning, or ML as it's often called, what is it? It's frankly a subset of AI where the focus is on using statistics to come up with models and algorithms such that the performance of these computer models and algorithms actually improve over time as you give it more and more data. So what does ML have to do with computer vision? Well, imagine it's like a Venn diagram, right? So you have ML here, you have computer vision, and they intersect. And so in this subset, you combine a hybrid of both techniques. And the tasks, the visual tasks, that I talked about, detection, recognition, these are, problems that can be solved only by using computer vision, but you can also use hybrid solutions. So you have these options. Now, stepping back a bit and going back to P&IDs, the question you might have for yourself is, or for me, is what's so hard about P&IDs, about learning from P&IDs? So in this slide, I try to address a bit of the, what's good about it, what's simple, what's hard, right? And what's a bit of a watch out. So the good news is, if you think about computer vision and, self-driving cars, for example, right, that go around and take sort of videos of cars as they drive throughout the city, you might ask yourself like, hey, wait a minute, these P&IDs, aren't they simpler than these, videos? And yes, you're right. These images are typically not real life, meaning they are 2D, projected onto a page. There's no kids, bicycles, pets, there's no motion occlusion, there's no illumination issues, right? There's no background, there's no, shadow, right? And color is often used to highlight and to mark up. And by default, a lot of these images are black and white. So yes, these images are actually much simpler than real life ones. But the bad news is because of the variation in the standards and symbology, notation, nomenclature, and the fact that different engineers care about different things when they work with these diagrams, there is no one size fits all solution. And then there's, in the watch out sort of section, there's also the fact that, the last 20% of work when you try to extract stuff from these diagrams typically takes 80% of effort. So that's the Pareto distribution at play. Now, in the next couple of slides, I go really quickly through the problems of detection and recognition, and I explain sort of the techniques from computer vision, and then ones from machine learning to accomplish both tasks. So the next set of slides are about detection. So if you wanted to solve detection via computer vision techniques, what is the approach, the classic approach to do this? And the crux of sort of detection via computer vision actually relies on the fact that you take an image and you can actually represent it as a feature descriptor, feature set. What a feature is effectively is it captures the information in the image's content, right? So here I have an example where you have, a face, and I've highlighted really features, right? Where you can see it's eyebrows, nose, eyes, mouth, ears, and that basically distinctively makes up a face, right? Good features are unique, not ambiguous, unusual, and actually capture points of interest in an image. Now, when would you use image features for detection? Well, they're great when you don't have a lot of labeled data and you actually want models to learn and update pretty fast. So when you have real-time, scenarios, for example, the trade-off is that you will have limited detection performance because you actually have to assume and choose, right, what kind of feature you want to use to extract, and represent an image. So here there's a list of image features that are actually quite common from the last 20 to 30 years. And there's an example here of a black and white image, and then the corresponding canny feature extracted output. Now, we also have an option to perform detection via machine learning methods. So here I've shown a deep network architecture, which is in the last probably 10, 20 years, is an emerging popular model in machine learning. And what's nice about these architectures is that you don't actually have to choose the image, the image feature you want to use. It's kind of baked into this sort of multi-layered structure. And second of all, these architectures can also do not only detection, but classification recognition 2-in-1. And so here, in terms of pros and cons, you do get superior detection performance. You can also get recognition baked in there, but then the trade-off is that you typically need a lot of labeled training data. And training is actually not only time consuming because of the bulk of data and complexity, right, of the model itself, but also the learning parameters are actually quite tricky to tune and optimize. If you think about each weight from each layer, you need to initialize those weights, set the learning rates, right, for each layer. And I've listed here some of the more popular and recent architectures from the last 5 to 10 years that have been quite popular out there. And then when we move to recognition, once you detect and you know where to look at in an image, can you recognize what you're looking at? So in terms of recognition, you can do it in different ways. You can do it via defining, say, a classification problem, and that's a space for machine learning models, or you can try to use, say, feature matching or feature indexing, which is much more traditional computer vision. So just high level classification in terms of, object classification, that is essentially composed of trying to figure out and discriminate actually between a finite set of classes based on image features. Again, image features come into play. So here's an example where you have a face and a bike, right? So a face, you could imagine, is composed of 2 eyes, a nose, a mouth. A bike has 2 wheels, right? A handlebar, pedals. And these are essentially the distinctive features that you would recognize to be able to map, say, an image and determine whether it's a face or a bike. Right? And then matching is another popular technique for recognition in computer vision, where this image below, you can see it's literally matching feature probabilities, right? And you're trying to then figure out if there's high correlation to indicate that this is the same object. And then finally, this is my last slide in this section, classification models in machine learning. This is one slide that really could take 6 months of instruction, but I'm basically trying to distill for you guys the crux, right? What's the main idea behind learning classification models? So you can formulate the problem in different ways, and I've kind of tried to visually depict on the top here in sequence left to right the different complexities and different sort of levers that you have. So first of all, you can actually define a binary class, right? Red or green, black or white, go, no go. And you can actually sort of separate the class linearly with a line, like a linear decision boundary. That's one. You could actually decide, I'm going to be more sophisticated and fancy, and it's going to be a nonlinear decision boundary, right? So that would be a nonlinear classifier. And then you can also have multiple classes. So here we have 3 classes separated by a linear, right, decision boundaries. You could also have an approach where you separate one versus all in terms of the classes. And then in the far right, you have the most complex scenario where you have multi-class and then nonlinear decision boundaries. Oh, and by the way, I've kind of assumed that the data is 2D, but very often, even though an image is 2D, the feature space is actually much higher dimension. And so you have linear versus nonlinear decision boundaries, binary versus multi-class problems, and then shallow versus deep, right? Network model architectures. And I've listed some examples out there of popular models that you might have heard for both linear and nonlinear. And that is the end of my section. And next will be Joe. Joe, you want to take it away?
Yes, thank you. I'll just start my screen share. So we should all be seeing the DataSeer UI. So for this first use case that we'll go into, or second in today's call, is the tag extraction. The idea behind this is we very commonly you'll find either in risk-based inspections or in other areas, you'll have a asset registry, master asset registry, and you're trying to detect all the tags off the diagram. I will zoom into this electrical diagram for a bit better visibility. With that, in trying to extract simply just tags, that user is now decoupling the necessity of that symbol to be present on these diagrams. Very commonly, it's simply just text and that they're looking for during this process. So with that, we can use computer vision to help expedite the capturing of these strings off of the diagram and have them placed in the CSV export so that data can be quickly collected and curated over the course of a project. So for today's example, I'm trying to pull all these strings that begin with this capital X off of the diagram. And with that, I'm going to navigate to DataSeer's text tab and use the search method. So our search method will take a regular expressions pattern to then create a search pattern that it will apply to all text on all the pages of, or just the given page of the project, depending on the scope that you choose below here. And with that, it will search for matches and then give us a one-by-one chance to review those matches to indeed confirm them. For today's example, as I mentioned, I'm just looking for the strings that begin with that capital X. So I'll simply just put this pattern to create that very generalized capture method. And down here, I can now tell DataSeer to either make this a generalized text object or a line number. Line number is very specific for the association with symbols. Text can also be associated with symbols as well, though it doesn't have a pre-script column in that export if you are creating attributes for symbols as an example. So with this, I'll search our current page. And we get a chance to review everything that's matching our pattern in a one-by-one approval or reject method. You can simply go and do this review, but as you see, we've captured 94 potential matches in this. I can simply go down to approve all if I was extremely confident that my regular expression was going to capture precisely the data that I want and exclude anything that might be an edge case that might match this pattern. You can get extremely powerful results with the more specific inputs you put to this tool for the process of capturing data. So everything, as we can see with a color, I'll try to zoom out a bit for the team to see. Everything that we've seen here with the color applied to it has been captured as a text object within the system. I can expand our menu on the left-hand side here. And all this data has been captured in here. If anything needed to be changed or updated, I can do it within this form here and then prepare it for exporting from the system. But with that, you're able to quickly capture those text, either objects to live just solely as a tag to be referenced in that, again, that validation step, or to be added as additional dimensions of information for symbols as an example. And that will conclude the text extraction use case. I'll go back to our project page and I'll open up this line designation table for our last use case of today's call. So commonly, you would find that users have to, going through a project, having to transcribe data that's held in tabular format into a digital copy off of a PDF file. That can be very time consuming. Both transcribing data has the human element of error batched into it, especially with the amount of data, as you can see on this page here. Additionally, having to capture and represent not just the scope, but the structure of these pages can be extremely difficult and time consuming as well. Using DataSeer, you're able to lift this information off of the page very quickly. And let me just zoom out to make sure we have the correct boundaries. So within DataSeer, I'll go to our tables tab and use this annotate tool here. And with that, I'm just going to create a boundary box around the data I want to extract. Then we just get a quick modal where I can tell DataSeer the style of table This could be for grid lines. It can be without grid lines, something like a bill of materials as an example. This could be notes on a P&ID you want to extract. Grid lines would be more applicable to a table like this or something like your data sheets that you want to pull data off of. I'll assign it a type. This is just for the way we bucket data in terms of tables within DataSeer. You assign it a type, and then we'd have other tables fall within that if we wanted to group them together. So I'll just call this a line designation table. And I can optionally give it a name if I so wanted to. And I'll extract it there. So DataSeer is now going to attempt to pull that data off and retain that structure. So as we see here, it did essentially, let me zoom in so we have a chance to reflect on both data types. So it's able to capture the data pretty much in the same space, given the breaking down within these different columns and the merging that will occur from one level to the next within our rows. And it's able to retain that data in the correct space. So it did. So foregoing the need to have to transcribe that. Though a user can go into this table themselves and manually update this prior to the exporting step, as this is now simply sitting in a database space for any kind of updates to be made. And just to speak to that structure, let me close this and expand on this one. So this is our now type, and our untitled one that we just extracted is now listed within there. And that will conclude the table extraction demonstration. I will return to the project page and I will stop sharing. And I'll pass it back to Brad.
That's all that we've got for now. Of course, if there's any other questions that you have, feel free to reach out to us. But for now, that will conclude our first webinar for 2022, the digitization of industrial diagrams through AI and computer vision. Hope everyone found this to be a valuable use of your time. I want to remind you all that you will be receiving a link to the recording of this session via email. Please be on the lookout for our next Q2 webinar invite, where we're hoping to actually include a panel discussion from some of our current user base. Feel free to contact us at info@dataseer.digital. Thanks again, everyone, for attending. Have a great rest of your day.